Hello, everybody. Here we are, 4.3 prisms and cylinders. We are going to be looking at the surface area of right rectangular prism. So, that means we have a rectangle on one side as our end and two congruent rectangles that are joined by four other rectangles. So a little bit of review. How do you calculate the area of a rectangle? So we did a decent amount of area kind of in the beginning. Remember, we were finding area of squares. But area is area equals length. This L means length times width. So here we go, length times width. So in a rectangle that has sides that are 4 and 6, the area or the length times the width, the 6 times 4 would equal 24 centimeters squared. Say we're using centimeters. So rectangles, the dimensions are length times width. Okay. So on the grid net I've provided, this is on the back sheet of the page that we're using right now, you are to calculate the area of each rectangle and write it on the net. So I'm going to go over to this right now. So you'll be on the back sheet of the page you were just on. And first, let's label all of the side lengths. So we just need to count them. This one is 1, 2, 3. Okay, so this is 3 right here. See that? This one is 1, 2, 3, 4. So that side length is 4. Make this a little thicker. This side length is also 4. This one I can see is 3. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one is 3. This one is 4. And you can kind of see how this is going to go from here. This one's 3. We got 4 here, 4 here, another 4 here, another 10 here, 4, 4. So either 10, 4, or 3. And now we're going to go through and calculate the area of each one. So we're going to go length times width. This one up here, we got length times width. 4 times 3 is going to be 12, and you could count them up. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the area that this space covers up. Let's do this one. Looks like we have 4 by, I didn't write that down, but this one is a 10 as well. These are all 10s. So this one right here is going to be 4 times 10, so 40. This one here is going to be 3 times 10, so there's 30 in here. This one as well is 3 times 10, so 30 right there. This one here is 4 times 10, so 40. And this last one down here, 4 times 3 is going to be 12 down there. So you notice we've got a 40 and a 40, we've got a 30 and a 30, and we've got a 12 and a 12. Okay, maybe I'll give you a second to write that down, and I can go back to our notes. So here we go. On the grid I provided, so we did that, write it on each net. Let's look at our rectangles. Okay, I listed them 1, 2, 3, 4, 5, 6. Okay, I don't know which one is 1, 2, 3, and 4, 5, 6. We can start, I guess let's call this 1, 2, 3, and then 4, 5, 6. Wow, I've got a lot written on here. So let's go this way, 1, 2, 3. So our first triangle is going to be 40, 30, 40. Let's go over here. So that one, let's do 4 times 10 equals 40. Then 3 times 10 equals 30. And then we did another 4 times 10 equals 40. That's for rectangle 1, 2, and 3. Let me check. That was right. 1, 2, 3. Okay. Then for 4, 5 and 6. Okay, we got a 30 and a 12 and a 12. So we had a 3 times a 10 equals 30. And we had a 3 times a 4 equals 12. And we had a 3 times a 4 equals 12. Okay, so give you a second, write that all down. And we need to find what is the total area of all 6 sides. Okay, so let's add them up. Let me get my calculator. We've got a 40 plus a 30 plus a 40 plus, here we go, a 30 plus a 12 plus a 12. 164. I'm going to say 164. I'm just going to call it units squared. Okay, we didn't necessarily know if they're centimeters, but they are square units. So does that make sense? Yeah, that's 70 plus another 70. That brings us to 140, and then plus 24, so 164 units squared. Okay. Let's move on. Calculating the surface area of a rectangular prism. So when you calculate the area of each side of a rectangular prism, as you did in the activity before, as we just did, you are calculating the surface area. I think of, we're going to be looking at surface area, and we're going to be looking at volume. And I think about the surface area kind of like your skin. It's like the thing that's on the outside that covers it. And the volume is kind of like how much space it actually takes up in the world. So the surface area is like your skin, and the volume is like you as a person with all of your skin and your insides and your guts and stuff like that. Sorry if that's graphic, but I think about surface area as the kind of outside thing, and the volume as the space in the world that it actually takes up. So for the given rectangular prism below, I actually put it beside. I changed your notes beside. We're going to calculate the surface area. So we've got side length of 2 and 4. So you could say it, and 8 is our other dimension. So let's look. If you think of it as a net, you will see that there are pairs of sides that are identical. We also call these congruent. So on the net below, label the rectangles that are the same. Label them as A, B, and C. On each edge, write the dimension. Okay, so I think we can just kind of see this by looking at it. This one looks like A, and this one is the same as that. Let's do this as our B, and I would say this is the same as that one. And finally, I would say we got a C and we got a C. And now they want us to label each side. So before, remember, we had 2, 4, and 8. I would say this longest one is going to be our 8s. These are going to be our 8s, our 8s. And I'd say this one is going to be our 4, our 4. It's going to be our 4 and our 4, 4, 4, 4, 4. And these little ones will be our 2s. That's a 2, that's a 2, that's a 2. A lot of really wild diagrams in these ones, so I hope you're doing all right, following along. And if I'm going too fast, you can just tell me to stop. So we did that. Now when you calculate the area of each face, you only need to calculate one of the matching pairs and then double it. Okay, so if it's true that this one is the same as this one, our A is the same as our A, and the B is the same as our B, and the C is the same as our C, we don't have to do it 6 times. We only have to do it 3 times and then double it. So let's go. Let's do the front and the back. What would we consider the front and the back? I think I'm going to consider A our front and our back. Oh, area of A. Oh, that's what it has. Okay. So that looks like we have 8 times 4. So 8 times 4, that equals 32. And because we have 2 of them, we're going to go 32 times 2 and get 64. What are we using? Oh, it doesn't say. Next, let's look at the left and the right sides. Oh, I guess I should have labeled those. I think that's actually our C, our B here. So the sides, the left and the right side. I mean, all these things really depend on which way the prism is standing. But okay, let's look at our left and our right side. Looks like we got 2 times 4. So I'm looking at this one right here. And that equals 8. And then because there's 2 of them, we're going to go 8 times 2 equals 16. And our last one, our B's, the top and the bottom, looks like it's 8 times 2. So 8 times 2 equals 16. And because we have this one and this one, we got to go 16 times 2, which gives us 32. Okay, so now our total area is going to be just those 3 numbers added up, plus 16 plus 32. So let's go 64 plus 16, yeah, plus 32 equals 112. I don't know. Let's do it again. Units squared. Okay. So what have we got left? This is our last page. Another couple examples. What is the surface area of this paper or gift bag that has an open top? Okay, an open top. The bag is 20 centimeters tall, has a base of 16 by 10. So let's look at the front and the back. So this side and that side back there. So it looks like it would be 16 times 20. So let's do that. 16 times 20 equals 320. And we got the front and the back, so we're going to times that by 2, and we get 640 centimeters squared. Now we got the sides, so it looks like this one here and that one over there. So it looks like we've got 10 times 20, which equals 200. And we got 2 sides, we're going to times that by 2, and we get 400 centimeters squared. And finally, it's a paper bag that's open at the top. So there's no top to this. We're going to calculate the bottom, which would be 16 times 10. And we get 160. But because there's no top, we do not double this. That's all it is. There's no top to this gift bag, so we're not going to double that one. Now, let's add it up. We're going to get a nice round number. 640 plus 160 plus 400 equals 1,200 centimeters squared. That seems like a big bag. Maybe, maybe not. Okay, and then this last one, what is the surface area of this child's toy block? The block is 10 centimeters tall, has a base of 7 centimeters by 5 centimeters. Okay, so the front and the back, and this is a toy block, so it seems like we're going to do the front and the back, we're going to do the sides, we're going to do the top and the bottom. It's got all of its sides and tops and bottoms. So the front and the back, this is the front. Looks like it's going to be 7 times 10. So 7 times 10 equals 70. Because we have the front and the back, let's do 70 times 2. And we'll get 140 centimeters squared. It's been squared. Next, let's do our sides. Right here, looks like it's going to be 5 times 10. So 5 times 10 equals 50. And we have both sides. So we're going to times that by 2. And we've got 100 centimeters squared. And finally, we've got the top and the bottom. Oh. So top and the bottom, we got both of them. So that looks like it's going to be 7 times 5. 7 times 5 equals 35. Got the top and the bottom, so we're going to go 35 times 2, and we get 70 centimeters cubed. Now let's add them all up. 140 plus 100 plus 70 equals 310 centimeters cubed. I like to think, when you have three three lengths, you're going to end up doing every combination. So you're going to do